Well, the next step on our journey to understand redox chemistry is to be able to balance equations that is happening for these reduction and oxidation reactions. So it's similar to the stuff that you would have learnt last year in year 11. So you're focusing on making sure that we have the same number of each atom on each side of the equation. That's one of the key things. So how do we tackle this? Well, we'll start with these half equations, dealing with a reduction equation and dealing with an oxidation equation separately before we combine them. We do this by, first of all, balancing the atoms in not oxygen or hydrogen. And then once we've done that, then we can balance the oxygen atoms, and we do that by adding water to the side that has fewer oxygens. Then we balance the hydrogens by adding H+. It's important that you include this plus because it's going to have an effect on this next bit here, that we've got to balance our charges. So this is what we didn't really have last year, but we're going to have charges, and we're going to add electrons to the side that is more positive so that we can have the same charge on each side. In redox chemistry, there are other things often in solution, but just not involved in doing anything. They're just hanging out there, kind of like spectating, watching what's going on. So these are commonly called spectator ions. So here we go, first example, and here we have dichromate going to the chromium 3+ ion. So rule number one is we balance the non-oxygen atoms, and on the left hand side we've got 2 chromium, so we need to put 2 on that side there. Number 2, balance the oxygen atoms. On the left hand side we have 7, on the right hand 0, so we need to add 7 waters because that balances the oxygens. Now we balance the hydrogens, and by adding waters to the right hand side we now have to balance these 14, 7 times 2 hydrogens by adding them to the left hand side, but we add them as H pluses. So now we've done all the atoms are accounted for, but now we have to think about charges. So on the left, so I'll start with the right hand side. On the right hand side we've got 2 lots of 3+. So this is a +6 in total on that side charge. On the left hand side we've got a 2 minus, but we've also got a 14 pluses. So this currently has a charge of plus 12 on that side, or 12 plus. So to make those the same, we have to add electrons, and we add it to the most positive side because electrons are negative. So I need to add 6 electrons to the left hand side for that to be able to be balanced. And now I have balanced my equation. I have 6 electrons plus 14 hydrogen ions, H pluses, plus dichromate goes to 2 chromium ions plus 7 waters. And we can see it's a reduction reaction. Reduction because if we analyze the oxidation numbers, each chromium's gone from the 6+ state to the 3+ state, or we can see it because the dichromate is gaining electrons, the 6 electrons. So if the electrons on the left, it's going to be reduction. Another example here is hydrogen sulfite going to sulfate. Now, balancing the non-oxygen or hydrogen atoms, 1 sulfur, 1 sulfur, so I've done that. Now to balance the oxygens, on the left hand we've got 3, on the right hand we've got 4, so I need to add 1 more water over here. I'm running the 3. H2, there we go. Now I balanced the oxygens, so now to balance the hydrogens, I've got 3 hydrogens on the left hand side, 1 in the hydrogen sulfite and 2 from water, but none on the right, so add 3 H pluses. And thus I have the last thing to do is balance the charges. On the left hand side is minus, on the right hand side is now plus, well, 1 plus 1, because of three positive charges and 2 minus charges. So I have to add electrons to the right hand side in this case, 2 electrons, so that they both will give now the same charge of minus. So that is how we do that. This is what is assessed for merit. You've got to be able to balance half equations. All right, so that's what you'll start with. I'm going to go the next step, so we know what we'll go to after this, but in the workbook there'll be first time practicing these two skills of just balancing half equations. So if we've got our two balanced half equations, we need to get the final one, which is the full equation, which is assessed for excellence, and basically we're combining them together. To be able to combine them together, we need to have the same number of electrons on each side. So sometimes it's easy, sometimes they both have the same number, sometimes you need to multiply one equation by a number, or sometimes you have to multiply both to find that lowest common multiple between the two. Once you've done that, you can add the equations together, reactants on reactant side, products on product side, cancelling out those electrons because they're both the same. And then any ions or molecules that are common to both sides, we can cancel them out, simplify that, and we can double check that we've got everything there in the end. So let's take this one here we've just worked out, and we can see we've got 6 electrons here and only 2 there. So I can't add them together because I won't cancel those out, but I only have to change this one here. I have to basically multiply the whole equation by 3, so I get 6 electrons on the right hand side for this oxidation part. So if I do that, I can rewrite that. So it's 3H2O plus 3HSO3 minus goes to 3SO4 2 minus plus 9H plus 6 electrons. Now the electrons are the same on each side, so I can add and cancel. So I'll cancel those out, and I will rewrite. So I'm going to, two ways you can do this. I could write what's for the dichromate, so the 14H plus Cr2O7 2 minus, and that's the reactants. Now I'm going to do the other reactants, plus 3H2O plus 3HSO3 minus. Okay, and then I need to complete the product side, which is 2Cr3 plus 7H2O plus 3 sulfate. And my head's in the way, so I'll fix this later. Plus 9H plus. Okay, so I've got my products and reactants on the correct sides. And now the final step, I need to simplify. I've got 9 hydrogens on the right hand, 8 hydrogen ions on the right hand side, so I can cancel them out and then take off 9 off there. So that will bring that one down to, I might change my color now. Change that to, I have now 5H pluses on that side, and then the waters, I've got 7 on the right hand side and 3 over there, so I'll cancel the one out, and so that makes 4 H2Os. Filling out everything else in though. plus 3SO4, SO3 minus 2Cr3 plus 3 sulfates. And that's balancing a full equation. This is one of a more complicated one where you do have lots of different things to cancel off each side. You've got to multiply one, but yeah, this is how you do it. Do one more example. I'll do one more example with this one here. So I'll start right from the beginning. I need to balance the half equations. Start with the top one there. Manganese, I've got one manganese on one side, one manganese on the other, so that's balanced. So I've got 4 oxygens on the left, so I need 4. Keep my pen going. 4 H2O's on the right. And now I need to balance my hydrogens. So I've got 8 on the right hand side. So I need 8 H pluses. And now my charge on this side is plus 2 or 2 plus. And on the left hand side, because I have 8 hydrogen ions, 8 pluses and a minus is plus 7. So to get those the same, I need to add 5 negatively charged electrons. So now both sides are plus 2 in charge. And that's the one done. Tick. Electrons are on the left hand side. This is reduction. The bottom one, I have no other non-oxygens or hydrogens, so I go straight to oxygens. Got 2 oxygens on each side there. So it's easy. Go to hydrogens. I need 2H plus ions. And then just need to balance the charges to 0 on the left hand here. So I need 2 electrons to get 0 on the right hand side. And this is a loss of electrons because electrons have come out of the reactant on the right hand side of the equation. Now this one here, you can see I need to find a common multiple between 5 and 2, and that is 10. So I need to multiply this by, the first one by 2 and this other one by 5. So easiest thing to do now is to rewrite them. So 10 electrons plus 16H plus 2 MnO4 minus goes to 2 Mn2 plus 8H2O. 5H2O2 goes to 5O2 plus 10H plus 10 electrons. Ooh. Now, unfortunately, I don't line them up perfectly with the arrows, which may cause a little bit of strife there, but we can see the electrons on the left and the right cancel. The only other common thing in this is just the hydrogen ions, because it's H2O2 and water, they're different things. So I've got 10 on the right hand side and 16 on the left, so I'll cancel 10 off each. Get rid of that one there. And so now, if I add them together, I've got 5H2O2 plus 6H plus 2MnO4 minus goes to 2MnN2 plus 8H2Os plus 5O2. And that's done. So that is balancing half equations and full equations. And hopefully that will be helpful.